innovation across the European battery value chain. I'm very glad to have you all here to start this new Innovation Uptake Event Series, which BEPA is organizing, and this is only the first webinar and the first step in this event series, and I will be going a bit more in detail in my introduction. As people are still coming in, I will wait still 1 or 2 minutes. Okay, I will start by giving a brief BEPA overview, as maybe some of you might not know so much about what we do. We are Batteries European Association. Our main mission and goal for existing is to work with the European Commission on the Horizon Europe work program for battery research and scientific research and innovation through the Bat4U partnership. So what we do really is through our different working groups and with the help of our 227 members who are all stakeholders within the battery RNI community, is to define the priorities for European battery research and innovation and translate these into the calls for Horizon Europe projects. And we have a total budget of 925 million euro to invest in battery RNI from 2021 till 2027 for the whole duration of the Horizon Europe program. And you know, being a member of BEPA, being a member of that community is really important if you're interested in European projects, as in European battery projects specifically, as it enables you to be part of that huge network of stakeholders who are all interested in working on the same thing, which is to bring the European battery value chain to higher competitive standards and also a sustainable, circular, and green battery value chain. So we really cater on the whole battery value chain, starting from the raw materials until the end of life and the recycling, with different degrees of intensity. And as you may know, Horizon Europe projects are scientific research projects, which go in general from TRL 4 to 7, depending on the type of action that is being led. And the idea behind our Innovation Uptake Event Series, which we are kicking off today with this webinar, is to undertake activities which will enable the Bat4U projects, which are funded under the Bat4U partnership, to better exploit their results, to really go as far as possible with the new innovative technologies being developed in these projects. And we see that sometimes in Europe we may struggle a bit to invest more on these new technologies and to industrialize them and bring them to the market. And this is what we want to address through these events, and really bring that sense of community around this innovation uptake ambition that we should all have. And I'm very happy then to be starting this today. So today we will be talking specifically about upscaling battery innovations throughout across the European battery value chain, how this works, and to really have a broad and holistic look at how the battery value chain functions and how you can best upscale your innovations within that system. So today's webinar is only the first step towards in this event series, and I'm already glad to let you know more about the next event that we'll be organizing, specifically targeting startups and training battery startups on elaborating and delivering their pitching decks and how to best attract investor investments, and so therefore receive help in upscaling their innovations and bringing them further. Let's say that on the 6th of May, we'll have an introductory webinar on this exact subject, which will give some general best practices and a presentation of an application process for the actual training workshop. So this 6th of May webinar will be open to all who are interested. And between the 6th of May and the 13th of May, you'll have a week to apply for a training workshop, which will take place on the 7th of June and will be open to 7 selected startups through the application process. And this training will then give some room for these organizations to attend a brokerage event in November 2024, which will be a pitching session for those who receive a pitching session in which they will pitch their business case, their technology in front of various stakeholders, including investors, industry players, public investors as well, public policymakers who can help you with your innovation and upscaling them. It will be also a great opportunity for many people to network together and to make the magic happen, as I always like to say, in order to bring these technologies further. And another thing that you will learn about later is that there will also be a training workshop specifically for researchers and startups that will also happen in June. Keep an eye out, as we will be communicating on this as well in the next few weeks. And with this, so today, what the agenda will consist of, we will have first a presentation from Julian Frumter right after, who will quickly present an opportunity for EU stakeholders, European stakeholders to cooperate with India stakeholders on recycling matters. And afterwards, we'll have Florian Deegan making a key presentation on the challenges of upscaling cell production in Europe. And I'm therefore happy also to say that you have a Q&A in the Teams, of course. You can ask all your questions here, and we'll be glad to answer throughout this today's webinar. With this, without further ado, I would like to give the floor to Julian, if you are available to present. So Julian Frumter is an advisor at the EU delegation for India, and we're very glad to have her today to present this opportunity for European battery startups. Julian.
Timothy, thank you so much for having me today. As you rightfully said, I am representing the EU delegation in India. Today, I'm an external consultant, mostly on innovation. I also run a company that's called My First Indian Client that helps companies to expand to India of all areas, not just battery recycling. But let's come to the call. We opened that call on the 9th of April, so very recently. Let me tell you a bit more. So the whole call is part of the EU-India Trade and Technology Council, which is an initiative that has been agreed upon between Madam von der Leyen and Prime Minister Modi as part of the regular consultations between the EU and India. And this battery recycling call is part of the Trade and Technology Council actions. To dive a bit deeper into it, we will have both solution providers, and I would consider the solution providers coming from startups, scale-ups, and innovative SMEs that operate in the space of battery recycling to benefit from this call. We will be selecting through this call 6 companies from the EU, and the Principal Scientific Advisors Office of India will be selecting 6 companies from India. And as part of the action, we will match those providers with adopters who are typically companies who are into battery recycling, who are building currently plans for battery recycling, already running them in both the EU and India, and we would select a number of those as well. Once we've select those, we will put everybody together in a virtual matchmaking event on the 20th of June to also find out who would like to work with whom. If there is shared interest, we will then go forward and provide a reward trip to 3 solution providers from each geography to bring them to the respective other geography. Timothy, if you can help me forward in the presentation. Now, I'm sure you are interested to understand what the benefits will be. Obviously, the Indian and the European markets are quite different. They have different needs, but also a lot of similarities, which we will, of course, share more as part of the action about. Now, what is the benefits for you to participate and to apply for this action? Of course, you will get exposure to the Indian market and the opportunities for battery recycling companies. We will help you validate your solution for the Indian market, make you understand where your solution fits, where it may not fit, and then narrow down into the opportunities that are there for you. You will have an opportunity to pitch during the virtual event that I already mentioned. And through the event and the outside, like the other activities that we will entertain, we will do matchmaking with adopters, influencers, policymakers, and potential clients in the battery recycling ecosystem in India. And vice versa, but of course, you would be interested to get to know more stakeholders in India. And from the 6 startups, I already said that 3 startups will be selected to visit electric vehicle battery recycling facilities in India, meet various stakeholders, and then also receive financial support for that trip. And then, of course, access and insight into the broader electric vehicle landscape of India, which is quite booming, especially in the 2- and 3-wheeler space. It's basically going through the roof, but also other 4-wheelers, buses, trucks. Many parts of the EV value chain are in high demand in India. So it's a fantastic opportunity to learn more about this fascinating EV landscape of India. And now a couple of timelines and dates that are important for you. The call is already open since the 9th of April. We will be closing the call for expressions of interest on the 30th of this month. So you still have 2 weeks to go to participate. There will be a form that you need to fill completely for us to consider your application. And then there will be a selection procedure throughout May that will include some selection on our end and then an invite for an interview to understand more about your solution, your fit for India, etc. And then an ultimate selection of the 6 participants that will come into the virtual event towards the end of May. And then the virtual matchmaking event will happen on the 20th of June. And we are planning the exchange trips to the other geography, respectively, in September and October, but would narrow down dates for that at a later date. But just so you have an idea of what the timelines for the action are, you see the QR code that Timothy created. Thank you for that, where you can find the link for the application and a lot more information that's relevant for. If you need any information, you can, of course, reach out to me. You can connect to me on LinkedIn, for example. And I can also put my email address into the chat box after I finish here. So you have all the opportunity to reach out and apply. Thank you, Timothy, for the opportunity to present the call. And I wish you a great workshop today.
Thank you so much, Julian. Thank you for presenting this interesting opportunity. Indeed, if you can put your email in the chat, that would be perfect, and so people can reach out. Moving on now. So now I will welcome Florian Deegan to the floor. Florian is the Division Director, Strategy and Corporate Development for Fraunhofer Research Institution for Battery Cell Production at FFB. He is today going to present a key presentation on the challenges in ramping up large-scale battery cell production in Europe. Florian, the floor is yours. Thank you so much.
Thank you very much. I hope you can hear me, see me, and see my screen.
Yes, perfect, all perfect.
Perfect, then we move on. Hello, my name is Florian Deegan. I will talk the next 20 minutes about challenges in ramping up large-scale battery cell production in Europe. The red line of this presentation, I would basically want to address 5 points. First, of course, introduction, battery cell production in Europe. What's the actual state? Then I want to, well, not just question, but also answer it, why is battery cell production so difficult? And to make it more concrete, I brought an example from electrode production within a gigafactory. Afterwards, I would like to show, okay, what are solutions to realize an efficient ramp up, what is done today, and what are maybe better, more efficient solutions in the future. So you probably know that, but it's such a nice introduction. Always the market of battery cell production is rising. I've took this map from batterynews.de, which shows quite nice when your gigafactories are constructed or will be constructed now and in future. And it says, you see lots of numbers there well, basically as of say June last year, 2,000 gigawatt hours of annual battery cell production gigafactories shall be constructed within Europe. So usually is like when you set up a factory, you have some KPIs you want to achieve. There's something like scrap rate, machine availability, speed, OEE, so overall equipment effectiveness. And well, when you are used to factory ramp up of products that you know scrap rates, well, you plan with kind of 4%. You have quite a high machine availability. Your speed is also quite high, you plan for. And yes, in the first year and second year, you will have some struggles, but regarding the overall equipment effectiveness, but you will learn and improve everything so that at year 5, you plan to have somewhat about 90% overall equipment effectiveness. But in battery production, reality looks a bit different. So if you really take the numbers which you get from different sources and also from insights from battery cell gigafactories, you will see that extremely high scrap rates, low machine availability, low speeds, and really low overall equipment effectiveness. Putting all these together means that even after 5 years, you will probably have a very inefficient factory. And this is how it looks like at the moment in gigafactories, which run, like for instance, in East Europe. But why is it this way? I mean, why is it so difficult, and why do you achieve almost 25% scrap rates? Well, I brought a very brief. Sorry, I see. I did not share with audio, but I will do so. Sorry for that. A very brief. Now you should see it again. A very brief clip of this guy. You know him, Elon Musk, who talks for 1 minute about challenge and ramping up. Not about Tesla, but about SpaceX. But I think it gives a quite good impression. So hopefully that works.
One of those things that you harp on so much is how you know, how that's so important, and that's in the long scheme the hardest part of all this. It's just the manufacturing.
Generally, manufacturing is underrated and design is overrated. So people generally think that like this eureka moment of like you come up with this idea and that's it. Now it's good, but the design, like there's literally 1,000%, maybe 10,000% more work that goes into the production system than the thing itself. So if you say like, how much effort have we put into, say, designing Raptor versus designing the manufacturing system? It's 10 to 100 times more effort to design the manufacturing system than the engine.
Even of Raptor?
Oh yeah, absolutely, especially with Raptor. All of our, basically, the amount of effort that goes into the design rounds down to zero.
Right.
Relative to the amount of effort that goes into the manufacturing system. Yeah. And if this was not true, great. I'd like 1,000 Raptors, please. Oh, you can't make them? Oh, okay.
Right.
This is like just very fundamentally underappreciated. If people have not been in manufacturing, especially manufacturing of something that's relatively new, then they don't understand, and they think the design is the hard part, and they think production is like a copier or something like that.
Right.
This is completely false.
It's definitely not as sexy.
Yeah, let's take it for now. I like that because Elon Musk, you know, probably the term production hell. This is absolutely true. Production is, or ramp up production system is extremely difficult. But why is it like that? So
as the end thing.
Sorry, I move on. Sorry for this. Now it should work, hopefully, again. Okay, so why is it so difficult? Let's take a battery cell, which you maybe as a startup produced in a laboratory. So you produce there around 0.01 cells per minute. This equals to about one battery cell each 1.5 hours. And you have some advantage if you do it in a laboratory, because you have a possibility of human quality control, you have a possibility of adjustment, repairs, scrapping, you have almost unlimited time, unlimited budget, and you have no subsequent commercial use liabilities. So you need to guarantee, for instance, that the battery prototype which you built there will last for 10 years and will work fine. If you go to large-scale production within a gigafactory, it looks a bit different. So you have 2,000 cells per minute. This is 200 times more or faster than in your lab. And there is no human quality control. There is no manual adjustment, scrapping. You don't have unlimited time and budget. And you need to be sure that everything works fine because you are legally liable. So this makes it extremely difficult. Just to show you that, I brought an example from a gigafactory. So how does a gigafactory look like? What you see on the left is a gigafactory plant project of power coal. You see 6 of these blocks. In each of these 6 blocks is one line, and this line usually can produce 10 gigawatt hours of battery cells per year. So you have a mixing, it starts with the mixing process, coating, drying, and so on. So now let's take a look on the coating and drying process. For those who are not familiar with that, a very brief introduction. Here on the left, you see such a machine. It's 100 meters long. Usually you have a small machine, not small, but a couple of meters of coating and an extreme long drying oven. And you basically take the wet slurry, coat it on a foil, and then here dry it. And the entire machine has, or the electrode has usually a width of 1.5 to 2 meters. So that's basically the width. And you coat with a speed of usually 60 till 80 meters per minute. So it's quite fast. And that means that you can, or you will produce in 1 hour 6 of these coils, 3 of these coils. So it might look quite small, but each of these coils is basically has a diameter of 1 meter, and in length it's almost 5 kilometers per hour, which you produce 24/7 on several lines within a gigafactory. So you might say, okay, what's so difficult about that? So then we coat or produce 5 kilometers of such an electrode. I brought an example from one of our pilot lines. So a brief question to you guys in the auditorium. Can you find the defect here? I give you 5 or 10 seconds. You see the defect. Just take a closer look. And maybe you find those, right? 2 defects. But did you find also these defects? Did you even know that these defects exist? Probably not. But now you might ask, okay, but I don't see anything there. What is the defect there? And is it that critical? So there are, at least that we know, 11 standard defects which can and which occur during coating. And this just in coating. And I brought one example here, agglomerates. Agglomerates is a defect which can happen quite often. It has a medium occurrence rate. And what's happened there is because of insufficient slurry mixing, you will have some agglomerates with an extreme small size of 0.1 millimeters. And this has 2 problems. The first problem is, well, because of these agglomerates, you can damage your production line later, the calendering. But the more important problem here is that these agglomerate can pierce through your separator. This might cause then a circuit, and this might cause then this burning car. And nobody wants that. The problem here is that not just these agglomerates could cause burning cars. There are lots of defects just in the coating who could cause burning cars, and nobody wants that, obviously. So if we take a step back and go through our coating process, you will have quite a lot of possible defects which could, not will or going to, but could cause burning cars. And this is something like you don't want to have. You don't want to have like one of these defects in your 5 kilometer long coils each hour on 8 different lines. So what are companies doing? Obviously, before taking risk of a thermal runaway, that's the technical term for burning heavy, thermal runaway, they scrap it. So that's the reason why you have scrap rates, high scrap rates. And of course, you drive everything smaller to achieve a good quality. But how do you want to, or how do you can avoid defects in a ramp up? So let's take a look on our battery gigafactory again. And let's take a look again on coating and drying. So if you want to coat and dry or optimize the process, so 0 defects, you need to make sure that you have good quality in and good quality out. Because if you have this problem with bad quality in, you can optimize as long as you want, you will always get bad quality out. So you need to make sure that your mixing process runs well, that you get good quality in, and then you can start optimizing, then get good quality out also on the coating and drying process. And if you do that in a subsequent way, you of course start with mixing, coating and drying, calendering, slitting, and so on, and so on, and so on, and so on. The problem with that is you probably need 10 years because it takes lots of time and you don't have 10 years to ramp up your factory. So what you do instead? Well, you of course try to optimize everything at the same time. This works, but it takes a lot of effort, more because you have lots of interdependencies. So it might happen that, well, let's say your stacking process is running well, then something is changed at slitting, and now suddenly your stacking process does not work sufficient anymore. On the other hand, you might see in a subsequent process, like in calendaring, that something with mixing was not right. So it's super complex, and it takes lots of effort to ramp up the factory this way, but you are faster. It takes about, let's say, roughly 5 years. It always depends, of course, where you start from, what's your level of experience. So now you could say, thank God, everything is fine, job is done. But what happens if you get the next battery cell generation? I mean, there are further developments like new slurries, new NMC with higher nickel content, or you go to LFP, whatever. Bad news, you probably need to do all over again. Of course, not start from zero because you achieved something, but it's not like that you just change, that everything runs well, you change the material and then everything works fine. No, you need to do this slight ramp up again. Okay, now let's say you are a battery startup and bring it, you have an idea, you have your first kind of prototype, you build your, let's say, solid state coin cell. What you see here is the development time separated in different MRLs, manufacturing readiness level. Some of you use the term technology readiness level, but in this case, it's the manufacturing readiness level. And you see here on the y-axis the accumulated profit or loss. So when you go on and move on, you have your prototype. You, of course, first need to build some more prototypes, like not from a coin cell, but like in a real prismatic cell. When you start a small batch production and somewhat, then you need to go on a gigafactory and start mass production. And it looks like that. And here at some point, you need to ask yourself, or the investor needs himself, shall we invest all this year in a gigafactory? And it's not just the infrastructure for a gigafactory. You need to almost pay a similar amount for material, energy, and so on, personal stuff, to learn how to produce. And well, many Asian companies, they are all through this already. They are, I don't know if they are already in the profit zone or on the way there, it doesn't matter, but they did this valley of death already. And lots of Europe companies, especially startups, are somewhat here and raise the question, shall we invest or not? And that's basically one thing what the German government addressed 5 years ago and said, okay, we want to make a kind of de-risk. We found the Fraunhofer FFB, the research factory for battery cell production, well, so that companies, and special smaller companies, startups, don't need to build their own pilot lines or gigafactories, but have access to a large gigafactory, which is basically kind of open source. So what is Fraunhofer FFB? Here are some important facts. We are located in the west part of Germany, in Münster, close to the Dutch border, and we're building a gigafactory. The German government is paying for that 700 million euros. The special thing about this is it is not a gigafactory for production of battery cells and sell them, but it's an open battery cell factory just for research and development purposes. We have about 170 battery experts, technicians, but also scientific staff. And just to give you some numbers, the entire factory will be capable of producing 7 gigawatt hours per year on the electrode side if we run the factory 24/7. But as said, we are not producing battery cells to sell them. Our value proposition is infrastructure. Here, infrastructure, knowledge, and innovations for efficient and sustainable battery cell production. So this is our main building. We have a smaller pilot line you see later, which will be opened officially by end of April, so in 2 weeks. There we have the first pilot line, and start of construction of this year is by fall of this year. So how does that work now? We basically have three and a half lines. The first line, it is no real line, it's an innovation space, but when you know battery cell production, you need a clean room and a dry room. So it's basically the half production line. Then we have a small line. This one goes online by end of this month. It is a coding speed of 10 meters per minute, and you can do first prototypes there. So 10 meters per minute is larger than most universities in Europe have, just to give you some ideas. Then we have, or will have, a medium-sized line with 30 meters per minute. 30 meters per minute is the size which, for instance, Northvolt has in its labs. So this is a standard pilot line size. And then we will have 2 lines on 80 meters per minute. So these are real industry scaled lines like you have in gigafactories, which are ramped up and set up and constructed right at the moment. And the idea is basically, if you have an innovation, you can start rent these small rooms, the innovation garage we call, and always scale up, but you don't need to go in an investment of own machinery, because you can rent these machines from us and basically pay by use and don't need to go into the risk. So summary, I think I'm quite good in time, maybe 1 minute over. What I wanted to show was it is extremely difficult to ramp up a battery prototype to mass production. It's the so-called, you probably heard that, production hell. The reason is that there are many unknown defects that can occur during production with the extreme high damage potential in battery application, the so-named thermal runaway. Thus, there are very high scrap rates in ramp-up of gigafactories, 10 to 20, 25%. And from our view, the only way to deal with this is start, fail, learn, and move on, but fail fast and cheap. And here, Fraunhofer FFB has a factory infrastructure, non-profit, where you can do this, or at least part of that. So that's from my side. Hopefully it could give you some interesting insights, some new aspects which you did not knew yet, and looking forward for the next presentations and also the panel discussion afterwards. Thank you very much.
Thank you so much, Florian, for this great presentation. Very insightful, very interesting, indeed, I can see everyone clapping. So many claps out there in the chat and from the audience. So thank you so much. I will directly give it to my colleague Bozorg from BEPA. You may some of you may know him, as he's very involved, obviously, in all that is the BAT4U RNI activities and setting up work programs for Horizon Europe and also Austria most recently. Bozorg, I'll leave you the floor. Also, please, for the audience, if you have any questions partaking particularly to Florian's presentation, please don't hesitate to ask them in the chat in the Q&A section available. And we can now move on to the next item in the agenda, which will be the panel discussion, which Bozorg will be moderating until the rest of the webinar.
Yeah, thank you so much, Timothy. And thanks, Florian. That was fantastic. That was really interesting. I'm going to start with if there are any questions from the chat. Otherwise, we start the panel discussions. Okay, so let me introduce our other panelists. I would like to invite Sebastian Moitzheim from Powell. Sebastian is the Chief Technology Officer of Powell, which is a producer of nanocoatings for lithium-ion batteries for cathode and anode material. And our other panelist, Kurt van de Put. Kurt is well known for BEPA audience. He's been involved with us and be one of the instrumental actors in developing the BEPA in past years. Kurt is the manager in the Battery Cell Competence Center in BMW Group. So thank you both. Thank you, Florian. Thanks all for joining us. So Florian set the mood, maybe the bad mood, but the correct mood, if you will, for the scaling. So let me start with Sebastian and just complete the list of challenges. So I would like to ask you, what was your basically realization of those effect points? What was that surprise picture for you? You're working more with the material part, so we're talking about a bit of a step back in the value chain. But what was the production hell that you went through? The most important ones. I know that they're numerous.
Thank you for the stage. Yes, of course. Even though we're more active in the material side, these things are also relevant for us. So I think high reliability, as Florian was saying, it should be good quality of materials coming in. Only then can you have also good quality of cells coming out. So we're on the side of producing the good quality materials. So it's really important that you take that into account when you design your process. And I think what's important to realize as well for equipment suppliers such as us and raw material suppliers is that by the time that you want to start developing your cells, so your A samples and so on, your components already have to have gone through almost 5 years of development. So because otherwise, like Florian said, if he doesn't get good quality components, then he can't really do his cell optimization. So and I think that's sometimes forgotten that the whole value chain, there's much more that needs to happen in order also for gigafactories to become successful. And I would say the challenges for us specifically are obviously good partnerships with our suppliers, because we don't have many suppliers around the corner. There can be very long lead times, so we need to take that into account in our development. But also specifically, we need to collaborate with material suppliers, because we do a post-treatment step. And those material suppliers also need to trust in our technology, trust in us, because they might share materials and components with us that also have sensitive information in it. So actually we're now at the pilot scale, so being able to produce at the ton scale, ton scale materials, yeah, you need a partner that is willing to give you tons of materials of good quality so that you can further develop your technology. And luckily, we have these partners now, so that's really good for us at this stage.
Okay, so let's shift to the other partners, your customers, and I'm gonna go again forward in the value chain and invite Kurt to the conversation. So I just want to start with a quote that I recently read. So it's coming from Jeff Chamberlain. He's the CEO of Volta Energy Technologies. It's a prominent venture capital investment fund for the batteries. So I'm quoting, quote, "We believe in Volta in part due to our experience with the semiconductor industry, that the automotive OEMs and even their suppliers, the battery makers, what they want is improved performance and cost with no change." So that really, I mean, is it a fair statement? So from your perspective, I mean, the number 6, the points that Florian made is that you need validation, you need reliability. There is a part that really is willing to take the risk. What's your take on that? Do you think that the small players take into account that threshold of risk that the customers are willing to take?
Yeah, I think that's really at the heart of developing technology. As a startup, is who's willing to take the risk for scaling up and for going through that production hell or going through that valley of death. So I think that's an important question, and obviously there are different incentives, there are subsidies that you can use, but I think you really need an end user, and in this case an OEM, to believe also well in the technology. If they I think all the OEMs, they want a differentiating technology, so and they want the performance, as you mentioned. I don't think they sometimes care so much about what goes in there. I think that's more about the whole supply chain needs to then align to make that a reality. But the question is, then who's taking the risk of pulling it through the valley of death? Like I said, by the time that they're interested in doing A samples development, there's already 5 years of scaling up. So I already have to be at pilot scale before even the cell development even starts. There has been a lot of risk that has been there. But I think it's really important to become part of the roadmaps of either your end users or your direct customers, because only then can you make sure that they see the long-term vision as well of that. I think that's the only way really to make it, is to really get on the roadmaps, make sure that your technology is actually scalable, and then of course do everything you can to prove that it is scalable.
Okay. What do you think, Kurt? Is that from your side? Are you not willing to take any kind of a change in your production?
If we would not be willing to take any change in the supply chain, of course, we would also not be able to innovate. So I think the one will never exclude the other. There's no innovation without change, right? But the key aspect is, of course, in managing risk. Doing business is having risks, but the risk needs to be mitigated. And risk mitigation in our case is, of course, thorough validation. And thorough validation means that we are interested in what goes in these cells, because it's only because we really know what goes in cells and understand the behavior that we can analyze and mitigate the risk. But I mean, we are in a very peculiar situation towards e-mobility, because we are all along the value chain in the same boat, in the sense that we all have to ramp up. So this is not a supply chain where 80% is constant, is stable, and there is a new entrant. And then you can talk about sharing risks. But in this venture for e-mobility, we are all already taking risks. And if people look to the left and look to the right to try to share the risk and convince somebody like, hey, you cover my back and I cover yours, that's not gonna happen, because we all struggle already to manage our own risk. So I think this is very important. But a key element actually in managing that risk is time awareness. I think people need to be very aware when they start a certain venture. If you want to be part of the supply chain, know from day one that it is for automotive applications, and that in automotive applications, the qualification times will take long. And if you are in the material section of that supply chain, that indeed you have to be ready before the cell making can start, because they want a stable material before they can optimize, and so on and so on and so on. So, and that's not new, eh? I recall the last 10 years, people showing the time to market for material innovations. And on average, it was said 15 years. 15 years between discovery of a good material and mass scale introduction into automotive. So this whole thing is not new, but it's about awareness. It's about time awareness. You can not promise immediate returns in this business.
I mean, what's your experience? Do you think that the awareness is just a bit lacking between all the newcomers, or you think everything is going in parallel? Because we talked a little bit about it, but and also Elon Musk also said that. So manufacturing is another piece. Is that awareness lost in the fact that this is an industrial kind of a transition, not a basically virtual transition? So what's your take about knowledge of that timings?
I would not necessarily point that awareness is not there because people don't really realize that they're in the industrial transition. I think everybody knows that, but on the other hand, with a lot of innovations, newcomers, startups, at a certain moment in time, the race to get to market and the pressure to get to market becomes so high that people start to be tempted to overpromise for whatever reason. and at a certain moment in time, reality kicks in, and I mean, reality is always there, doesn't escape, and that's when it sometimes gets sour.
Okay, thank you. So let me ask Florian about a bit more about the reality. So you've done a number of studies on that. You showed us the procedure of principally the cell manufacturing. So when you look at from the techno-economic perspective, when you look at these numbers, so when you consolidate that with the scaling itself, so increase the number of output, what really highlights there? From within the cell manufacturing, also if you take into account other parts of the value chain. So how does that basically number of defects, how does that irregularity in the manufacturing is within the plant itself and also dependent on other parts of the value chain? So your supply, in reality, this supply really changes those numbers, or is the application, how do they affect these numbers?
So a question is basically how the defects that can occur in a factory relates to defects in a supply chain before.
Yeah, we talked about you talked about the fact that this is a very high scrap, so numbers are divert from the ideal basically planning from the beginning. The one major part that you talked about is what it happens within the gigafactory itself. But other factors outside the gigafactories, how are they basically affecting this?
Okay, so it's not just about defects. I mean,
defects
it's
in a general sense.
Well, it's more about well, there's so many challenges. Not just, I mean, defects this is a technical issue, but let's start. So first is like legal obligations. In Germany, it's BImSchG, so emissions. Then you have energy costs. I mean, energy costs is, we didn't expect it, to be honest, in the beginning. So we thought, dry rooms, it's probably a kind of dry room, not that much investment, not that much energy costs. And then we got surprised what a dry room is and how much that costs, like investment, but also energy costs. And energy consumption prices. This is another big challenge. Then you of course have the technical problems with as said, defects, high scrap rates. At least in Germany, now for Germany, it's another the staff, technical experts who did that before, who can run a coding machine and see works this fine or does this not work fine. Well, basically, you don't know what is important or what is important. There is no experience. So basically, you don't have just one fire or two or three fires you want to distinguish. You work on 1,000 problems at the same time, and somehow it works. I mean, what else can you do, right? But I think there are so many challenges. Another thing is uncertainty. Where do we go in future with which cell chemistry? I remember a time 3 years ago, everybody said LFP is dead. Nobody wants to have LFP. LFP is just for buses or for the Chinese market. Now Tesla has LFP, and LFP is coming back. Not because it's superior in technical aspects, but it's cheaper, so business case. Then questions like the format, cylindrical, pouch, prismatic, all this changed the entire time. And if I check on LinkedIn, I have a feeling there is always this, next sodium ion at the moment. 2 years ago, solid state. So what is next? What I need to kind of assess and then make a decision. Okay, do I stay with my plan or do I make the change? Because the change might be the better choice, or do I stick to the plan, even if it might be outdated? uncertainty. So there are so many things, especially uncertainty and lack of knowledge, that makes it very difficult. Well, it's a challenge, difficult, maybe the right or wrong word. It's a challenge which I think we need to take.
Yeah, exactly. So Sebastian, how do you face that challenge? So you probably hear I mean, I guessing that it gives you chills if someone talks about completely different material and you say, oh, what should we do? What's the coding process for this and that? Like, I'm sure the news affect your general process a lot, but how's your strategy in absorbing that kind of a dynamics and uncertainty?
Yeah, thanks. So we're lucky in a sense that our technology is not specific tied to one material. So we can play into different materials development. So from nickel rich to the LMRs to the different design to cost or design to performance materials. But it is very crucial that you realize that when you start developing your components, you're not really competing with today's components. You're competing with the components that will be out there in 5 years. And since it takes you at least 5 years to get somewhere, and the whole market is working on it at the same time, you need to also predict to some extent, okay, what do I need to deliver in 5 years' time that is really gonna be game changing. So I think for us that has been quite interesting. For example, focusing initially on NMC 811 and realizing quite quickly that actually NMC 811, even though in Europe it's not so widespread yet, but it's getting there. It was already at mass production scale, at least the materials, and hence there was not so much appetite to try new technologies in the production of those kind of materials. So you really need to look already to the next generation of materials, and that of course makes it very hard because I also hear constantly changing. Sometimes now it's LMFP that is going to be big, which is also a recent development. Is it going to be now we're going back to mid nickels and increasing the voltage, so it's changing really fast, and that's really challenging. So you have to place your bets somehow hopefully in a clever way and pick the right one.
Yeah, I mean, the idea that you can, but let me ask you to that end something else. So how do you accumulate that knowledge? You are dealing with a limited number of material now, but do you have a process of making that know-how somehow established within your company? Because we talked a lot about the fact that we should not really going around the circles when we deal with the new technologies and etc. But how do you deal with that kind of accumulation of knowledge within your company for that?
Yeah, so of course, even though I said we are platform technology and we would love to do everything, we have to focus, obviously. Otherwise, we can't keep up. So you need to make the right decisions, and I think it's really important that you do that together with. We have to work together with, in our case, with material suppliers because they have bigger teams. They also know very well what they're doing. So that's what I said before. You need to really build trust with them. So that, of course, on our side, we want to make our technology understand and develop our technology as good as possible, but that we can also leverage the knowledge and developments that are happening in big corporations in that side. So I think that partnership and that open innovation is really important.
Mm-hmm. So I would like to ask Kurt about that. So that partnership, when you are in that kind of level of partnership with a smaller player, so you yourself are a big player in the industry. When you see that kind of a potential of a new technology, that kind of a disruptive options, and you have a perception of the scaling timing, how do you consolidate that in your own company roadmap? When you see, okay, this is coming in 5 years, how do you see the process of scaling? How do you see the potential that a new technology gives? How do you make a sense of them and put it into your own documents, basically?
Yeah, that's not a straightforward task, of course, because yeah, you have to make sure that there are well-defined entry points of breakthroughs. I mean, you cannot enter a breakthrough technology every other quarter in your product line, and certainly not in automotive. But even in the supply chain, I think you really have to define this well, discuss this well with your supply partners, and this is exactly what we almost. I mean, I would say that we constantly do. This is not something that you bring on the table with your supply partners every year in a high-level management meeting, and now let's discuss and to see when we can introduce something. You are so integrated in that supply chain that you have to play open cards. This is going to be such a challenging thing if everybody stays on its turf, and every quarter comes around the table and has a price negotiation and has an arm wrestling exercise. It's not going to work like that. You have to jointly discuss and look at the opportunities. And the difficulty is indeed to forecast what is the state of the industry going to be in 5 years or in 7 years from now, and take that into account. Here, I mean, with my team, that's also the difficulty. What is the technology status in 7 years from now? What is the cost level at 7 or 8 years from now? So do the things that we look at, do they have the potential to contribute to a better performance, a more stable product, or a lower cost? This is a harsh task, but on the other hand, other companies, I mean, do that as well. I don't think we are now so special and so unique. The semiconductor industry has also a 2-decade-long roadmap in front of them, and they also work like that. Why would it not be possible? But the semiconductor industry is, in the meantime, in that sense, technologically innovative, integrated. They pool their resources. They have an industry roadmap. It's all efforts go in almost a kind of well-coordinated roadmap, and then every supplier and every semicon maker gives its own flavor to it. But it's a concerted effort, and I think we will have to get there as well. Otherwise, we're gonna kind of create costs and create delay in our supply chains, which do not benefit. After all, they do not benefit the customer. The customer wants a reliable and affordable electric car. That's what I want.
Exactly. So to that end, so Florian, you talked about you are in the business of de-risking, so you are in the business of making that kind of a uncertainty minimized. So let me be specific about FFB and your facility. So when you are facing with that huge list of technologies, solid state, LFP, whatever, do you have I'm guessing that you must choose two. So do you have a kind of a criteria of the priorities? For any startup approaches, you tells I'm gonna revolutionize. I'm gonna add 30, 40, 50, whatever % to the energy density. No. So do you have basically a list that you choose from?
So first of all, if there is a startup who says, I have the newest LMFP or solid state battery and I want to try it at your factory, of course they can. But the question is more like, okay, if we have to invest our own money in something, I mean, in our direction, what do we choose? So we basically evaluate different kind of technologies or formats. We did it in a published white paper a half year ago about sodium-ion batteries. Now we're planning to do it also with someone of you named it LMFP. So at the last couple of weeks, everybody is asking about LMFP. So this seems to be kind of the new material, and maybe in a year there will be another new material. Fair enough. So what we do is we evaluate it, and I mean, how do we choose where to start? Because we are limited to a certain amount of projects as well. So what we developed for us is kind of we analyzed in a factory, where does it hurt? So where is CapEx high? Where is OpEx high? Where is scrap rate high? Where is energy consumption high? So for instance, if someone says, hey, I would like to improve the speed of a calendaring process, we probably would say, yeah, okay, but calendaring output is not the bottleneck. You have probably other challenges which are more important. So, and there we have kind of a rating regarding of time, energy consumption, quality, footprint, costs, where we say, okay, is there kind of a red flag or a red heat map? Okay, this is red, we need to do something here because there is cost high or bad quality and things like that. And we use this mechanism to see, okay, where do we start and where we maybe start in 3-4 years, and where technology feels where it's not worth it to go in at the moment because there are other low-hanging fruits, so to say, which should be taken. So this is basically our job. And what I really liked about the comment before is this roadmap. We find it extremely, what we would like to have is a kind of European roadmap or kind of, let's say, open source European battery cell, which everybody can use or modify, a bit like the Google operation system. It's open source, but everybody can take it and modify it. But somehow it's extremely difficult to bring all on the table and say, okay, we go this way, because someone says, yeah, but I want this and this and this and this and this. And everybody wants to be part, but you can't do everything. You need to make a kind of standard, and then you can go like the next step, maybe 2 standards, 3 standards, a point where you modify it. This is something I would really like to see, and I think it's possible, but it takes time. And as said, it's always important to have some sponsors not in a financial way, but companies, big companies, to say, okay, that's interesting. Because if there is no OEM who says, okay, I go this or this is the right way, there's so many, well, you need a first mover who's big enough and says, I take the risk, or at least a part of the risk. So hopefully that gives some more answers to your question. But a European battery cell, just open source, this is still something, well, hopefully we will go there once.
Perfect.
But Florian, you're saying, is there an OEM interested in it? I mean, you are producing cells, so in the first place, your partner should be the cell makers, right?
Yeah, no, we're not. No, we're not producing battery cells.
Should be aligned with the industry, right?
Pardon?
You should be somehow aligned with the industry, overall industry. So
yes,
in a certain sense, a natural partner for discussions and challenging should also be the cell makers. The OEM is a customer, but you would expect that the cell maker, to a certain extent, is driving a roadmap for cell technology, right?
They are important stakeholder. Yes,
absolutely.
So I think there is no yes or no answer, because there is always someone at the value chain who brings this added value. At the end, as you said, the customer wants to have a achievable car which is running, and then says, okay, like more luxury or more like a cheaper way, and then everybody in this value chain has to take a part of that.
Yeah, I would like to add something to what you earlier said on you need to prioritize and you need to look where the pain points are as an innovator and focus on that. I would like to elaborate on that point towards, let's say, startups and innovators. I see still, against all textbooks available, but I still see a lot of innovators and startups making the mistake of too fast proposing something that comes out of the technology gut of the innovator, but that is not tested enough towards application of the real need. And and they get stuck there because they offer something that is only half cooked, that is not ready, and that doesn't get the attention by almost nobody. And that's where they end up in a kind of a very difficult period. So it's much better to test things in more depth, analyze very carefully what your potential customer really wants, and if needed, take 2 years longer to develop. And I know this again, 2 years more financing, but we are getting to the risk phase again and the timing. But this increases your chances for success so dramatically. I see this also in our lab. Now we get a lot of proposals, a lot of things are suggested, but very often it is not well enough tested towards the application. This is the key remark that we usually have to give to the products offerings that we have here in our lab to test.
Can I add a comment to that? Because the question is, where can they test that? I mean, who has this pilot lines? Who has the money for this pilot lines? And this is usually BMW and the big OEMs. And if they come to you and say, I would like to test, and you say you're not ready, which is completely fine, I would argue probably the same. Then the question is, where else
it's not
can
about
they
volume.
go?
I don't focus on the volume. It's not the scaling. It's about better testing if it is suitable for the problem that needs to be solved. We get too often, I think, suggestions that are so technically interesting, and oh yeah, very nice, exciting, but the test towards the application is missing, and that is crucial. That's really crucial. Volume comes, scaling comes later. That's true. Where do they have to go? But you have to get to the first hurdle. You have to pass the first hurdle. Yeah, and many startups miss that.
You mean building a prototype, or do you mean just
prototype? Depending on the technology, is your innovation in the production, or is it in the material level? That's a completely different approach, of course.
Maybe I can add something to this. So what I hear and what is very interesting is what Florian mentioned. Look, if somebody comes to FFB and they say, I want to make a better calendaring press, we can tell them, hey, that's not the problem. And I think that as a startup, and that's also a bit related to what you said, Kurt, okay, what's the application? What problem are you actually trying to solve? And in that sense, the FFB fills an interesting role because you can tell them, hey, these are the problems that we're having because you're already doing it. So if you could make less defects, or if you could have a much faster qualification process to test whether there are defects, etc. So knowing these problems is half of knowing the actual problems you're trying to solve as a startup. That's half your game that you need to do. And I would say that what we have been facing and the issue has been is that, for example, on the material production side, actually being able to visit a factory where materials are produced, it took us a very long time before we had enough trust to get there. If there would be a let's say an open innovation center for cathode material development in Europe, maybe the specific issues I would have known them much faster, and then I could have tailored my technology much more to the actual problems that are happening in the industry. And I think you could think of the same thing from raw material extraction to material production to components production and then cell manufacturing and then recycling again. I think for each of these steps, having these kind of FFBs would be really great because then we would actually know what are the problems that we need to solve.
Can I add on that? Because that's a really, really good point. On one hand, so nobody knows where are the problems of the battery cell manufacturing because the big companies don't tell. We really had lots of discussion with Asian companies, with German automotive OEMs, and super confidential everything. So there is almost no chance for someone who's not there, who never visited a gigafactory, to get information what is the problem which has to be solved. With all respect, the companies, and there are good reasons, like the automotive industries, I mean, there is a competition, right? And of course, there is IP protection. But the downside of that is if you don't talk about it, if you don't talk about your problems, nobody will help. All the people will come with ideas which don't have an impact. So there's always a downside. And everything is fine, completely understood. But I think everybody has the same problems with dry rooms, with energy costs, and things like that. And I notice sometimes discussion where people don't tell about certain things where everybody knows, hey, everybody has this problem, but this is an open secret, so to say. This is something where I sometimes wish a bit more transparency, seeing where are problems that can be solved. But I, of course, understand right now at the moment this uncertainty. You don't know what you can tell or not. So it's a dilemma, I would say.
That has to do with the maturity of the supply chain and the industry. So much more mature industries typically have across the globe, even expert groups where things can, under of course the right legal umbrella, but that indeed common topics are being discussed, are being explored. But this industry is too young still, and there's too much at stake at this moment in time. I don't think we can expect that.
Yeah.
Now, when I reflect about the last hour, and I would be a startup leader right now, I would be probably a bit depressed. But I want to still focus on the fact that without all these innovations, we would be far less advanced than we are advanced now. That's very important. And secondly, we often, specifically in Europe, we always think like, how is it possible? And how can we ever come to a competitive gigafactory in Europe and so on and so forth? So difficult. But I mean, the reality, battery industry isn't smooth yet. And it's also in Asia not smooth, or it's in North America not smooth.
Exactly.
What I find striking is that almost we as Europeans, we don't know anymore. We kind of forgotten how difficult it is to kick off a new industry because we barely have done that the last 30 years. Successful industrial operations need blood, tears, blisters on your hands. That's what it takes to make these things happen, right? So, and we have to fight for that. We have to push. I'm still convinced that there is no fundamental reason why you would not be able to run a battery plant effectively in Europe, and whereas you would be able to do so in Asia. There is not a fundamental reason for that. We can argue about a bit of cost differences left or right, east or west, but also these things tend to change and go in a bit in a pendulum. So it's going to be rough, yes, but we have to just push and resist and get it done. I mean, my first experience in the cathode material plant was in Korea 25 years ago, also with blisters on the hand. So this is really what we have to get through and be determined and get there. That's really important. And it's on the industrialization like that, and it's going to be smart innovation that needs to kick in. We need strong academics. We need skilled people. I mean, we can miss people that think that the development for batteries is over and that subsidies are to train new PhDs that is no longer necessary in batteries. I mean, it's up to all of us to do the missionary work and say like, hey, this is not built in a year. Work on that diligently, and 1 year will be more difficult than the other, but we have to push and go for it.
That's really fantastic. So a lot of underrated stuff. The challenge, the timing, the interconnectedness of the value chain. So we went through this back and forth of the role of OEMs, the role of C. But I think at the end, it's just there must be a bit of loosening of that kind of a guard, and communications between different parts must be faster and smoother. Thank you so much, all. I want to take a couple of minutes. So I have to mention this. So this is a busy week in Brussels, and a lot of negotiations here. We have the European Council talking about the competitiveness, the financing of the green transition. We have reports at the high level about the European competitiveness, single market, etc. So I want to take a chance, give you each 30 seconds, 1 minute to talk about that side. So we are in the midst of all these industrial policies. We are seeing the battery strategy coming out from different organizations, but with this specific focus on the small player, what is being overlooked? What is being from the public side? Is it just the funding? Is it just the or the other parts are also there? The priorities are there. We have the perception of the timings, as you mentioned, Kurt, the industrialization, the perception of the industrialization and the time that it takes and the challenge that it takes is undermined. So what do you think? What do you think about that? If we are with all this constraint that the EU is experiencing now, financially, geopolitically, etc., what are the politicians in a general sense are missing about the small players and the scaling in principle? Please, just 30 seconds or 1 minute, Max, please. Let's open the Pandora box slowly. So it's a huge.
I think what we actually miss is a stable ecosystem. I mean, it's the uncertainty to develop either innovation, the uncertainty to grow the industry that makes it so difficult. I mean, look at certain companies. They built a factory because they have a permit. The permit is revoked. We are years later, and that factories are standing idle. I mean, how can we work like that? How can we work like we make our lives really also extremely difficult? And there has been an enormous trajectory. If I look back the last 5-7 years on what we have achieved in Europe, the mentality has shifted. There are good initiatives, but nevertheless, yeah, we make our life still very difficult in industrializing things. And on the one hand, providing money to innovate, providing help to build certain things, but then not creating the operating conditions to get these plants running. Yeah, that's
not enough capex.
That's double, but that's double, that's double bad, because you have invested in training people, in innovation, in industrializing, and then just stop.
Yeah, exactly.
You let it loose. I think this is what we try to need to change.
Keeping track of if we are building an industry, we should keep track of every aspect of it. We shouldn't really just, it shouldn't be momentarily. Everything should be constant. As the industry itself, the growth of it needs constant care. Perfect.
Yeah.
Florian?
I'm thinking about that because we're in a quite good situation, right, with all our funding. So there's to say more is not really appropriate.
Is it in Germany? It's like that? Is it in good shape?
It's not really appropriate. Well, two things. One, content. I said that what I would really like is, I mean, everybody did in the last couple of years a job orientating himself and his or her companies and wondering, okay, what is my plan? What is the situation? And now we all learned basically to walk, not to run and jump, but to walk. And I think, well, putting things together like a roadmap or some mutual projects, like I said before, that would be nice. Regarding content, because then you can use synergy effects. If everybody uses the same open cell format, there are so many synergy effects. Suddenly, you get recipes and things like that. This is something I would really like to see. The other thing is, well, I mean, our business at Fraunhofer is, of course, writing research proposals. And what I noticed over the last 10 years is the extreme long time. So you need to wait for the right well, let's say, request for proposal. Then you write the proposal, which is like 60 pages long. Then you wait for the answer and things like that. It's not just about Europe, it's in Germany and things like that. And I know many companies which say, okay, great idea, but please no public funded project. It takes too long. So we will have first results like in 3 or 4 years. This is something, I mean, there are good reasons for that. Please don't understand that as critic, but we really have companies which say, okay, it's too difficult, or then we need too many from this country and this country, or this area of Germany and things like that. So sometimes it's for us more difficult to find the right partners and build the value chain and things like that than well, making a proper proposal and the idea. So these are challenges. I know there are good reasons for that. Completely understood. And I think it's good this way, but sometimes we're struggling with the time. With the time and all, okay, you need this and 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 this. And it feels sometimes that the idea of innovation makes just 10% because you need to build your consortia and funding ratios and all this. You know this. You're from the business.
Thank you. Sebastian, please.
Yeah, I think I would build on what Florian and Kurt says. Is basically, I think money is there to fund this development, these innovations, but it's indeed the speed at which the money ends up somewhere that takes a long time. I mean, when I read about how much funding is available and how much funding has been spent, and it's sometimes, you know, years before things arrive at the end, then you wonder, yeah, but you need those years you could have spent on developing the technology. So why does it take so long to get there? So that's, I think, one key issue. And if I would have another advice or suggestion is to focus on the whole value chain. So the whole supply chain, basically, because now we're very much focused on cell manufacturing, which is good. And, you know, there's the FFB and these kind of initiatives. But if we want to be competitive with costs, we need to also maybe we need to be extracting and making our own graphite. Maybe we need to be recycling and have the technology in the house, because if you need to get all your equipment from abroad, from Asia, to make all those things in here, you're still dependent in a way on Asia, because the EU wants to process 40% of the materials here in Europe. But if you don't have any material, like no supply chain that can actually produce the equipment and can do all of that, I think that's an issue. So cell manufacturing, a lot of focus on cell manufacturing, that's good, but I would suggest also to focus across the supply chain and see that they also get attention as well.
Thank you so much. Yeah, exactly. Just like the raw materials. Please,
risk mitigation. Yeah, risk mitigation also means supplyability. Yeah? And I think we are not mitigating risk if we focus too much and are too stringent on it has to happen here. Yeah, that's a longer term goal to maximize that and to balance that well, availability over cost. But on the short term, it's going to be a mix of everything. Otherwise, we will never get there.
Yeah, absolutely. So let's hope that we can continue on these paths and localizing the knowledge, supply chain itself, the circularity that should be complementing that localization and basically de-risking the any kind of uncertainty. But thank you so much. It was an amazing conversation, and we went a little bit over time, so I'm giving the floor to my colleague Timothy for wrap up. But I'd like to appreciate your contribution very much. So thank you so much.
Welcome. Thank you for being here.
Thanks.
Indeed, I can only confirm that it was an amazing conversation. Thank you so much to the four of you for your contributions, your great insights. Also to those in the chat for your interrogations, but also your participation comments for some. I'm very happy we had this. I will have to wrap up the webinar. I'm sorry for those questions that may have not been answered. I would just like to remind you that we have a upcoming webinar specifically for startups in particular to kick off a training round for them, and also later there will be a training workshop for researchers in particular. So that will be happening from the 6th of May all the way till June. Thank you so much for your attendance, and of course for all the participants for your presentations and conversations. It was great. It was very great. Very great. Very interesting, and we'll see you next time for the next BEPA event. You can always contact us for more information on our activities. If you have further questions, you have our emails here that you can use to contact us directly. Thank you once again, and well, have all a good afternoon, a good end of the week, and until the next time.
Thank you. Bye-bye.